Hello, fellow developers. Today we're gonna solve the Leetcode problem 2 sum. It's part of the Blind 75 problem list. For folks who do not know what Blind 75 is, it's a comprehensive list of DSA problems which are curated to better prepare for interviews. Here we also will be utilizing something called as hash map, and our solution is going to be in TypeScript. Without any further ado, let's dive right into the problem. So we are given the array of integers nums and an integer target, and we have to return the indices of two numbers such that when they add up, they sum equal to target. We can make the assumption that there's exactly going to be one solution, so we don't have to worry about multiple solution, or there's not going to be any solution at all. The indices should be in the order. So if our solution is like 0, 1, we can't return 1, 0. The element, even if they are equal in value, their indices should not be the same. So we should not choose the same element twice. Let's look at one of the examples. So we got this nums array 2, 7, 11, 15. Our target is 9. So if we look into this, we can see if we add 2 and 7, that's going to equal to 9. Basically, that's our answer. And we have to return the indices. Remember, we don't have to return the element. The index of 2 is going to be 0, and the index of 7 is going to be 1. So it's going to be 0, 1. If we look into this, 3, 2, 4, the target is 6. And what we have here, if we add 2, 4, that's going to add up to 6. So this will be 1 and 2. Yeah, that's pretty much the same over here. 3 plus 3, that's going to be 6, and 0 and 1 are the indexes of that. And there's only one valid answer exists. We are expected to come up with an algorithm which is lesser than O of n squared time complexity. Let's think of like the brute force way of solving this problem. So essentially what we'll be doing is we can have two for loops and then I and j, and then see if I plus j equals to the target, then we just return the I and j. And that's going to be a solution, but it's for two for loops and it's going to take up a time complexity of O of n squared. But we do not want that. We want to use something better than that. So that's where the hash map comes in place. So we are essentially using hash map here because we kind of want to store the index with the element. So that, if there's an element which may add up with the current element to the target, then we want to retrieve the index and return it back as an answer. So this is a modified version of the first example we had. So we know the solution is going to be 2, 7, and the corresponding index of that is 0, 3, which would add up to 9 in this case. And that's the target we want, but that's the desired result. So this would be a solution in this case. How are we going to do that? And this is where like a map comes in. We want to store the element and the index together, right? So what we will do here is the logic we are going to deploy over here is if we have an element which has not been encountered before and its complement doesn't already exist in the map, then we are going to add it to our map. So let me break this down, okay? So we have 2, right? Currently our map is like empty, so we're just going to add that, and its complement doesn't exist in the map. We will store the element along with this index. Now let's move on to 11. All right, let's find its complement. So that's going to be -2 in this case, right? That's the complement of 11. Let's say our -2 was the first element instead of 2. Then we already found a solution, right? -2 and 11 is that's going to be the solution. 0, 1, that's going to be the solution, but that's not the case. So what we'll try to do is, this is a potential candidate for a part of the solution, but we do not know that yet. So let's add that up. 15 is going to be the next element we encounter, and we're going to see if its complement exists in the map. And again, that's not the case. We'll just add that in the map. And then we encounter 7, right? Now, our 7's complement, that's going to be 2. And we know that that exists in the map, which means we have found the solution, right? So we will not be adding that to the map. Rather, we'll just return the index. So we will retrieve the index of 2. When we loop through it, we know that it's going to be I. So we'll just send that back together. So that's the solution. Let's try to code that up and see if we truly understand that. I'll be coding this in TypeScript. Let's define the map. All right. So in JavaScript, this is how we actually define it. What we will try to do here is we'll be looping through array once, right? Let's compute our difference, all right? And that's going to be this. What we will see is if my map has that difference, we are essentially going to return the elements index, right? So that's going to be the difference element. When you remember the example, we got like the difference being 2. So that's the element. So that's index is what we want. We'll get that index and our current index. That's going to be in the example, that's going to be of sevens. So that's what is going to be our solution, and we just written it directly. Otherwise, we want that to be added into our map, right? So we are just going to say our element along with this index. That's pretty much the code. I know we are guaranteed one solution exactly, but just in case if there are any edge cases, we can just return an empty array. This is the entire solution. Now let's see if it works. All right, it works perfectly. That's it, guys. Thank you for watching the video.